Section 2.4 is graphs that can be misleading. The objective here is to understand how improper positioning of the vertical scale can be misleading, understand the area principle for constructing statistical graphs, and understand how three-dimensional graphs can be misleading. Statistical graphs, when properly used, are powerful forms of communication. Unfortunately, when graphs are improperly used, they can misrepresent the data and lead people to draw incorrect conclusions. Sometimes this is done intentionally, especially by advertisers, and we're going to look at some examples where incorrect positioning of the vertical scale can be used to mislead consumers. Also, incorrect sizing of graphical images can cause information to be misrepresented and misleading perspectives for three-dimensional diagrams. Objective 1 is to understand how improper positioning of the vertical scale can be misleading. The baseline of a graph or a plot is the value at which the horizontal axis intersects with the vertical axis. With graphs or plots that represent how much or how many of something, it may be misleading if the baseline is not zero. This is one of the things that will cause a graph to be misleading. Notice both of these graphs represent passenger traffic at Denver International Airport, and we go from 2006 to 2012 on both of these graphs. Both of these graphs actually represent the same thing, but at first glance they don't look as if they do. We see that on average it looks like we've had about 50 million people plus or minus a few between 2006 and 2012. But if we just look at the top piece of this graph and start the graph at 47, which would be about right here, you see how we're just taking the top, ignoring everything that's below because it's all the same. We see an exaggerated differences here. This is one of the reasons this graph is misleading. Both of these graphs actually represent the same information, but because our baseline doesn't start at 0, over here it starts at 47, we've exaggerated the differences here by stretching out this vertical distance on the bars. These graphs are based on the same data but give different impressions. The graph on the right has a baseline at 47, which exaggerates the differences between bars. This is a graph that an advertiser used. They both represent the miles per gallon fuel consumption of the Honda Civic, the Chevy Aveo, and the Toyota Camry. Both of these graphs represent the same thing. Looking at the graph on the right, we see, well, all three of these cars look like they have over 30 miles to the gallon, and they get roughly the same MPG. Toyota Camry's not quite as good as the Honda Civic, but the Chevy and the Honda, there's not that much difference between them. But if I cut this graph off at 30 and just blow up the top portion of the graph, it looks like the Toyota Camry is getting maybe a fourth or a fifth even the gas mileage of the Honda Civic, and that's just not the case. We've exaggerated these differences, but both of these are accurate graphs or precise in the information that they're displaying, but on first glance and first impression, this one makes it look like Honda's the way better vehicle. Toyota would not publish this graph. Toyota would publish this graph. Honda would be more inclined to publish this graph. You can also have misrepresentation with time series. The same misleading information can be created with a time series plot. If we start our time series graph down here at 0 for the baseline, we see that there's not a whole lot of difference between the passenger traffic at Denver International Airport. But if we start our time series graph at 47 with 47 million passengers as opposed to starting down here at 0, we see these exaggerated differences in the time series. It makes it look like there's been a more dramatic shift in passenger traffic at Denver International Airport than what there's really been. Objective 2 is to understand the area principle for constructing statistical graphs. We often use images to compare amounts. Larger images correspond to greater amounts. To use images properly in this way, we must follow a rule known as the area principle. The area principle states that when amounts are compared by constructing an image for each amount, the area of the images must be proportional to the amounts. For example, if one amount is twice as much as the other, then its image should have twice as much area as the other image. The cost of jet fuel in 2013 was 83 cents per gallon, and in 2013 it had risen to $2.87 per gallon. Note that the price in 2013 is about 3.5 times the price in 2003. This bar graph gives you an accurate visual representation of the cost of jet fuel in 2003 and 2013 because it looks like about 3.5 of these bars area for 2003 could fit inside of this bar that we have for 2013. It works that way because the width of the bars is the same and only one dimension, the height, is changing. But if I represent the same information using a picture, it looks like we could fit way more than 3.5 of these little airplanes inside of this big airplane. That's because my dimensions have changed not along one axis, but along two. When we're finding the area of a rectangle, we multiply length times width. If the length has increased 3.5 times, and the width has increased 3.5 times, when I find the change in the overall area, I would do 3.5 times 3.5, which gives me 12.25. That means that according to this visual representation of the area of this picture, we've got more than 12 times the difference as just looking at the area of the picture, and that's misleading. It gives the overall impression that the price change is 12 times greater in 2013 than it was in 2003, and that's just not the case. That's why we use bar graphs that change only along one dimension, because the bars have the same constant width. In the bar graph on the left, the area for 2013 bar is about 3.5 times that of the 2003 bar. In the picture of the planes, the difference appears to be much larger. The reason is that both the height and the width of the airplane have been increased by a factor of 3.5. Thus, the area of the larger plane is about 12 times the area of the smaller. The airplane graphic violates the area principle and gives a misleading impression. Objective 3 is understanding how three-dimensional graphs can be misleading. Newspapers and magazines often present three-dimensional bar graphs because they're visually impressive. Unfortunately, in order to make the tops of the bars visible, these graphs are often drawn as though the reader is looking down on them. You can see the perspective here is looking down into a box. This makes the bars look shorter than they really are, and it's hard to get a good visual representation or a good idea of what the author intended you to see. At the end of this section, you should know the common ways that graphs can be misleading. This would be incorrect positioning of the vertical axis. This happens when we don't start our baseline at 0. Incorrect sizing of graphical images by not allowing for the area principle. And then three-dimensional graphs distort perspective. And this wraps up section 2.4.